Hello, we are from Group 5. So we are going to present for the PBL assignment. For the introduction, proportional integral derivative PDI control is the most common control algorithm used in industry and consists of three basic coefficients: proportional, integral, and derivative, which are verified in order to achieve optimum response. The response of setting the optimum gains for P, I, and D to get the ideal response from the control system is called tuning. The PID controller's gains can be obtained by the methods of trial and error. In the meantime, they are also helping to control the maximum overshoot. Only one PID controller will be used for this assignment. The PID controller has optimum control dynamic as well as zero steady state error, fast response and no oscillation, and a higher stability where both high starting torque and control operating speed are required. The PID simulation can be modeled using MATLAB Simulink to provide accurate PID tunneling simulation prior to the device testing. Next, the methodology. Firstly, we need to derive the mathematical model equation, and then we simulate the DC motor plant, and then we determine the parameters to the implement P, PI, PD, and PDI controllers. Next, we obtain tuning automatic and manual for PDI controller. Then we simulate the response for T equal to 5 seconds. If the simulation is fail, we go back to the obtain tuning automatic and manual for PID controller. And if the simulation is success, we analyze and record the data. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. And hi doctor, my name is Fahir Ashraf. I will explain for the result and analysis and also the simulation, the Simulink MATLAB. So the first, we need to solve the problem that given the equation. So this our calculation by using the data. For the input is voltage Vm, then the output is X, the motor position, and lastly we get the transfer function. This is our transfer function, and then we need to control the position of motor. We use the PID, and then the PID controller use a Ziegler-Nicholas tuning formula and route stability precision condition. So this is our family parameter for the PID calculation. And then we go to the simulation. So this firstly is our M file, and then we go to the Simulink. This is our Simulink. This step is the finite is 0.8, and then it's the PID controller. We can adjust what we want, P or PID or PD, PI. So we see for the PID, this is our calculation that we get. We put the calculation at this, and then we run. We get a graph. This is our graph for the PID controller, and then we get the overshoot is 40%. The rest time is 0.11 second. So we go to automatic tune PID. We go to the PID controller, and then we go to tune, and we get the result from this. This is our result for auto tune. The overshoot is 10%, and then we can adjust for manually to get the below the 10%, and we can adjust more for the lowest overshoot. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syah Nizam bin Hishamuddin. And for the conclusion, the method using for PID controller design is the Nichols method. The loop tuning can achieve the optimum performance in order to obtain the desired control response. And 3. The simulation for the position of DC motor is in MATLAB Simulink. And the final block diagram can achieve by calculating for the all the equation of parameter of the DC motor. The result in graph with the transfer function of the equation. And using the PID, KP, KI, and KD can stabilize the graph. And lastly, the control response is directly proportional to the overshoot but reduce the steady state error. Okay, for the recommendation, one of the recommendation can be increased when the loop rate to improve the performance of PID controller. With the current technology now, the PID can run loops up to the 20 kHz using NI compact field point controllers. And second, to further extend the PID performance on system that can change over time by using another variant depends on the dynamic for the system. And last, by optimal the controllers using linear quadratic controllers can be improved the improvements on the system based on the design specification, which is calculating the cost algorithm. That's all for today. That's all for me. Thank you.